Okay, let's begin with question number 8. I'm going to move the question to the whiteboard, please. So the straight line L passes through points A and B, whose position vectors are I plus k and 4i minus j plus 3k respectively. And the plane P has an equation x plus 3y minus 2z equals to 3. So given that L intersects P, find the position vector of the point of intersection. So how do we go about this first part? Okay, when they say that the equation of line L, so the equation of line L will be, so you would write something like this. So yeah, we take the point that is given, which is fixed, I plus k, and then plus, you need to take something in the direction of the 2 points on that line. So to represent the gradient, so what we do is take a lambda as a constant, and we subtract the 2 given points, because in vector is something like a direction, sets a direction when you take that. So let's subtract this 2, please. So this means that we take the 4i minus j plus 3k, and then we subtract, so minus, so in another bracket, it will be I plus k. So I plus k like that. So then we get this one, then we simplify this plus. So it's the equation of line L. So it's quite straightforward to see there's 4 lambda plus 1, just treat it like algebra, the ijk, and then join the j. Oh, there's more things there, sorry. I think I'm doing too fast, getting confused, sorry. Let's do it slowly a bit. I plus k plus lambda, let's do in the bracket, please. So it is 3i minus j, 3k minus k is plus 2k, plus 2k like that, huh? Just take that. Okay, then we multiply it out. Okay, correct. Yeah, let's just double check always. Let's make sure it's correct. And then this becomes something like 3 lambda plus I, sorry, plus 1 of the I. And then the second one is minus lambda j. And then the third one is 2 lambda plus 1k. The ijk like this, equation of the line L. Okay, now this, they say that they want to find where it intersects P. See, when they intersect the plane P, so on the plane, the x, y, z coordinates are connected according to this equation. So this is the x, y, z coordinates are connected. So this is x, y, and z like that. That means what I'm trying to say is x is 3 lambda plus 1, comma, y is minus lambda, and z is 2 lambda plus 1. Now using this equation, let's try to solve it together, please. So x plus 3y minus 2z equals to 3. Okay, let's try to substitute and say. So 3 lambda plus 1, right, plus 3 bracket minus lambda minus 2. So bracket got 2 lambda plus 1 equals to 3. Okay, let's simplify this further. Plus 1 like that. Minus 3 lambda minus 4 lambda minus 2 equals to 3. Just a careful calculation would yield the correct answer. So we can see that this becomes minus 4 here when you move everything and clear the thing. And then the other side, it becomes 4 lambda. So in other words, we can see that lambda equals to -1. So they want the position vector of the point of intersection, means we need to substitute this into this part. Okay, please ignore this thing. Later I'll tell why I put it here. Just 2 things. So lambda equals to -1 and this part. Okay, then for the intersection, the lambda is -1. So the position vector at this point would be, so we just substitute lambda equals to 1. Okay, let's have a closer look at that, please. So 3 minus 1 plus 1 of the I. Okay, and then minus lambda is minus of the -1 of the j component. And then the k component is 2 times minus 1 plus 1 of the k. Sorry about the overlap there. It's just a simple simplification at this point. So this becomes minus 2i plus j and minus k. Minus 2i plus j minus k would be the answer to the first part. Minus 2i plus j minus k. Yeah? Okay, let's do the second part, please, now. Okay, so find the equation. So I'm just going to write that position vector, the point of this thing, minus 2i plus j minus k. Minus 2i plus j minus k. Minus 2i plus j minus k. Okay, so I write the answer. Okay, let's go for the second part, please. So in the second part is find the equation of the plane which contains the line L and is perpendicular to the plane P, giving answer in the form ax plus by plus cz equals to 1. Do notice that the general form that a1 equals to 1 is given. So we're going to use that format. We call it a format. So the first thing that we need to use, the two facts here. The first fact that we want to use is actually given from Wolfram, from a very beautiful maths website with a lot of facts in that. This is this, a normal vector. See, when it's a plane equation is given like this in Cartesian coordinates, ax plus by plus cz is plus d is constant 0. It doesn't depend on the d at all. If you notice carefully, the normal vector is actually something like this. It's ai, three-dimensional, plus bj plus, what do we say? ck. It's a normal vector to the plane, the gradient. Somebody call it the gradient of the plane itself, normal plane. So as you can see, delta f, yeah, okay, the normal vector. This is what they're talking about, a definition, a particular definition. So the normal vector is like that. Okay, they use this normal vector to calculate, let's say, the equation of a plane, like it was given in this way. So I'm just putting it down here, but we are not actually using this formula. This is called the standard formula because no point is given. So we need to do something different. That's what makes this question a little bit tougher, and it's worth 6 points. Yeah. Okay, now what is the different thing we need to do? So first, let's talk about the normal. What is the normal equation first? So the normal vector is with respect to which plane? So the normal vector here, or the n, just put an n like that, is based on which is the equation of a plane. And it's perpendicular to this plane, right? Perpendicular to plane P. So that is why I just read off the coefficients. A is 1 there. So therefore, I just put an I. So A is 1 means I. B is 3. So 3j plus 3j. Or I plus 3j and take the coefficient of z minus 2k. We don't care about that. 3 on the other side, the d. The d is not a thing at all. So the normal vector on this plane will be I plus 3j minus 2k. Okay, repeat that. I plus 3j minus 2k. And then we need to get a few other things. And what is it? What is the use of this normal vector? This normal vector, they didn't write here, but we must understand that normal vector means 90 degree. So it makes 90 degrees to the, to the plane P, right? So it makes 90 degrees to the plane P means we can just take the plane P there, change it to I, X, Y, Z, the coordinate, the part, and then do a scalar product. It must be 0. And that's the logic. So second part, using the normal vector, how? We need to use the scalar product is 0. So scalar product, okay, of these two, that means the plane one is x plus this thingy, right? So the normal vector in that. So what we do is, we just multiply. But there is a nice way of doing determinant way. We can take the scalar product. Oh, sorry, it's not a scalar product. It's a dot product. Is 0. Yeah. Mistake. It's a dot product which is 0 when it's 90 degree, right? Cos of 90 is 0. Yeah. Sorry, it's been a while since we do that. So we're going to multiply the two, and see to make it 0. Okay, let's try to do that, please. So we need to take the okay, let's multiply 1, 3, and negative 2. So from here we take the 1. Here we take the 3 dot product and negative 2, as though this is this thing, coordinate thing. And our plane is the A, the coefficient of that B, and the C. So a scalar product actually here is actually 0, huh? So I'm confusing that wording thing lah. Okay, so A plus, let's look at that closer, please. Let's see, B times C. A, this one times that. Aha. Okay, just multiply only lah. So in other words, we just take a direct multiplication. Okay. So A, 1 times A, plus 3 times B, plus minus 2 times with the C, the constants there, equals to 0. That is how we know that that's how you must satisfy the normal, that is 90 degrees to it, normal vector to the plane. So we can use this shortcut to get the equation, the first equation here, A plus 3B minus 2C is equals to 0. Okay, this is our first equation. So I'm just going to call it the first equation here. Take a screen grab of it. Later we need to solve that to get the value of ABC plus. Okay, let's take this. It's been a while since I did this vector geometry. Okay, it's not always been do this thing sometimes. Okay, let's just put it there. Okay, let's continue for to get the second equation. So what is the second equation that we need? So the second equation is going to, we're going to use the fact that, the next fact is that the point A is on point A, which is on L, right? Point A on L is on P. So when you put the equation on P here, see, and the point A is I plus K. Okay, the I plus K means, okay, let me take a drink of it. Why is something else? Sorry. Okay, so the I plus K, the coordinate there is what? So we just want to think in terms of three-dimensional coordinates and not the vector. That means we take it as IJK. So the coefficient is 1, J is 0, K is also 1. Aha. So let's substitute this into this equation of the 3D equation here for the P. So here we have, this one is X is 1, this is X, Y, Z. Please take note. So we substitute directly to get quite simple. We get the X means A, this part is easy, plus B is 0 times 0. C is, Z is 1, right? So plus C equals to 1. So similarly, now I'm going to do for point B likewise. So for point B, let's do it together, is on the P and L, because, so it satisfies both the equation and just blah, blah, blah. So therefore, if its position vector was 4i minus j plus 3k, then that would mean that its coordinate as x, y, z coefficients respectively with 4, -1, and 3. So just of the x, y, z, so the x, y, z part. Okay, and then I'm going to substitute it into here. So into that equation, the orange equation there. A is, so 4a minus b plus 3c equals to 1. So we're going to label these two as equation 2 and 3. So then we realize that we can solve this because the 3 variables, 3 unknowns. So that's what makes this question a little bit unique and tough also to see these things. So we're able to see all this, then it becomes a little bit more solvable. Okay. So let's take the third equation as well. If I clear the screen, I want to keep the question on the left. All right, in this case. Okay, now let's try to solve this 3 simultaneous equation and get the values of A, B, and C respectively, please. Okay, let's just substitute first the A. From the top one, we can see that C, let's say we use equation 2. Okay, equation 2 tells me that we can substitute C as 1 minus A. Okay, in both 1 and 3. Okay, as follows. So in equation 1, it becomes, okay, so A plus 3B and then minus 2, the C is 1 minus A, like that, equals to 0. Okay, let's simplify this a little bit, please. A plus 3b, or let's double check just in case. So minus 2 plus 2a is 0. All right, so then this becomes 3a plus 3b equals to 2. 3a plus 3b equals to 2. Okay, let's do the other equation, then I'll tell whether I want to use it this way or how. Let's put it in equation 3. So equation 3 becomes 4a, okay, minus b plus 3, c is 1 minus a. And substitute equals to 1. All right, so we just need to rewrite this plus. So how does it become? So 4a minus b plus 3 minus 3a equals to 1. 4a minus 3a is a. Then this one you bring the other side. A equals to b minus 2. 1 minus 3 is negative 2. Huh? Okay, then we know already how to solve this. This is 4. This is 5. Okay, let's put 4 in 5. 5 in 4, sorry, and solve. Then this becomes 3a. And this is 3b equals to 2. So the a is b minus 2. Okay, let's try to solve this one. So 3b minus 6 plus 3b equals to 2. 6b equals to 8. And then from which we can deduce our first value for the equation of the plane, which is b equals to, there were 2, 4, right? 4, there were 2 is 3. Yay, we got the base 4, 3. Okay, let's try to squeeze up the answer here on this particular place. So putting this in, so let's say we put this in 5, please. So a becomes b minus 2. So 4, 3 minus 2 is 4, 3 minus 2. That's right, it's a nice fraction. A is negative 2 over 3. Okay, then we can put this back in this one. In one or this one. Okay, so in here, this equation C is 1 minus a. Let's calculate that also, please. At the same time, C is 1 minus a. So placing the a is negative, therefore becomes a plus. So that means that in terms of an improper fraction, C would be 5 over 3. So what are the implications of these 3 values? C is 5 over 3. Yeah? Okay, so the equation of the curve, therefore, is it true? A is negative 2 over 3. Yeah? A is negative 2 over 3. And then B is 4 over 3. C is 5 over 3. Yes, these are the correct numbers. And therefore, we can write finally the equation of the plane in the form, because they want in this form. So I just used the 3 blue values. Please take note, just write it here. So it's just rewriting negative 2 over 3x. We just follow the instructions. So 4 over 3y and plus 5 over 3z equals to 1. Thank you.